Welcome to The Tech Between Us, brought to you by Mauser Electronics, where we help empower innovation together. I'm Raymond Yin, Director of Technical Content at Mauser Electronics and host of the podcast, The Tech Between Us. In each episode, we'll have a technology conversation between our tech experts, technical representative from our manufacturer partners, prominent academics, and industry thought leaders. Today, we're talking with Dr. Mathieu Bloch, Professor of Electrical and Computer Engineering at Georgia Tech, about 5G and the future of robotics and automation. 5G is without a doubt the dominant topic in wireless today. Even my 86-year-old mother has heard of 5G, and like many, she has no idea what it is other than it's one more than 4G. However, unlike 4G, 5G has capabilities beyond just connecting us to our social media. Mathieu, what makes 5G so different?
Well, excellent question, right? If you hear all the hype and all the buzz that's going around 5G, that's a totally legitimate question. And I think to understand that better, it's good to see where the Gs are coming from. And the Gs have really been following the natural evolution of the cellular communication systems. How they've evolved from analog voice to carrying digital data, not just your voice, but your text messages, to now carrying video, and you can essentially surf the internet. And if you look at everything that's happened up to 4G, really the key driver behind the G was improving speed and throughput, so that suddenly you could go from watching a low resolution image on a computer or your little phone to actually streaming Netflix and full videos in HD on your latest smartphone. But really, again, the drivers have been improving speed, improving throughput. What's really changing with 5G is that it's not just about speed and throughput. It's actually a big umbrella that's meant to encompass what people have designed as three major topics. The first one is what's called enhanced mobile broadband. And I have to almost apologize. It's hard to talk about communications without doing a little bit of jargon, but I'll keep it minimal at that stage. That enhanced mobile broadband, it's, I think, the natural extension of 4G. It refers to the ability to have more speed, more throughput. But what you want to have in mind is that the kind of applications are beyond just watching video. And people are thinking virtual reality, for instance. So that's one of the key applications that people have envisioned. Now, 5G is very different for 4G because it envisions other types of communication. One of them is called machine-to-machine type communication. And what that really refers to is the idea that now, the pipelines provided by 5G are not just going to be about, delivering a video to an end user. That's going to be about allowing different devices that don't have any human in the loop, like sensors, in your smart home, talking to actuators in your smart home automatically without any human intervention. And that's a very different requirement because devices don't have the same requirements in terms of quality of service, the kind of data that they transmit compared to humans. And the last pillar of 5G is something people call ultra-reliable, low-latency communication. And that is exactly what it describes. It means the ability to communicate almost instantaneously without any perceivable delay in a way that's ultra-reliable, meaning that you're almost guaranteed that your bits of information actually go through. And that's going to be critical to allow new applications such as telesurgery, where a doctor would be able to operate on a patient that's thousands of miles away. That's going to be critical for autonomous driving and vehicular networks. So these are the three big pillars that make 5G so different from 4G. It's not just about improving speed and improving throughput. It's about envisioning a whole new range of applications and enabling applications we're not even thinking about today.
Right. So 5G is capable of doing all three modes simultaneously across the same network?
Yeah, exactly. So that's an excellent point. One of the key innovations behind 5G is the ability to tailor the network to the application that's being run. If you think about the way cellular networks work right now, essentially you have a cell phone. Let's say you're one with service provider X. What that means is that your phone connects to a base station that's owned by cellular provider X, and it's routed through their network, and eventually it reaches the internet. I'll simplify that a bit, through a gateway, and that's when it's being handed off to the rest of the world. With 5G, what people have envisioned is providing much more flexibility. And they're providing the ability to disconnect, if you wish, the physical infrastructure from the network infrastructure, which means that suddenly, you might run different services, say, on your smartphone, and the network operators that actually run, say, your virtual reality part are different from the one that will run the voice communication part. And that's crucial because these two have very different requirements, and you need that flexibility to make sure that the network is tailored to the application that you're running. That flexibility is one of the key innovation, and people like to hype the word revolution a little bit, but I think 5G is really trying to disrupt what we've done with cellular networks. And I think it's a trend that we're going to see more and more. I think the new Gs are likely to bring in more innovation, a broader range of application. And to be fair, they might not all be perceived by the end users, but there's going to be a lot happening behind the scene that will be perceived by the user in terms of the services that we run.
Right. And I've also heard that, as a technology becomes ubiquitous, like a 5G or whatever, it just absolutely disappears to the user, and it is seamless, and everybody just uses it.
No, absolutely. And, people have talked about the Internet of Things a lot, right? This idea that we're going to, drop devices in our environment that talk to each other, and that can go from your doorbell. A lot of us might already have smart doorbells that are connected to a network, to your toaster or your fridge that tell you, if your bread is ready or if your fridge is empty. But that goes beyond, right? Automating factories, automating your home. And these things will be transparent to the user. The user doesn't want to know that these things are actually there, but to enable this IoT, this Internet of Things, you need a backbone communication network. And that's where I think 5G has a huge role to play. It will provide the infrastructure and the core that will enable all these applications and allow them to run, as you mentioned, completely transparently to the end user.
That is terrific, yeah. And that seems like it's going to be more in the lines of the second use case that you mentioned, the massive machine type communication.
Yeah, absolutely. And perhaps, I'm going to start making predictions here, which is always a little bit dangerous, but it's always good to think about, where are these things likely to be deployed first? I mean, 5G by itself is just, it's a protocol. So it's a set of rules that dictate how we should do the communication, but then where they are deployed, that's up to, the end users, to the companies, and that's very much driven by markets. But if I have to take a bet, I think we'll see a lot of that happening in factories. I mean, people are talking a lot about industrial automation, and for that to work, you need a communication backbone. And 5G, especially like deploying all these sensors to create an IoT, that is likely to happen there. Because now you have to imagine that if you have the right network infrastructure, you can start deploying sensors on a whole bunch of machines that before had to be inspected manually, for instance. And so 5G is going to really play a key role in enabling what people call predictive health maintenance. The idea that you can monitor remotely different pieces of equipment and send a technician to repair them or maintain them just as needed and predict when they're about to fail. And you can imagine the huge savings in cost, but also the huge improvements in efficiency. So that's one application. The second one, I think we've already seen some of that, even though that's not super widespread yet, are autonomous vehicles. Autonomous vehicles, we like to think of, cars that run automatically, but the reality is, if you have one car that runs on its own, it's essentially a very smart robot on wheels. But if you start having multiple cars running autonomously, then suddenly you have to start thinking about how they will interact with each other. And I think that's where having a communication backbone that enables all these vehicles to interact with each other is going to be key. So I suspect 5G is going to play a key role here to enable fleets of automatic vehicles to run smoothly.
Absolutely, yeah. I think definitely on a more larger scale, in smart cities and metropolitan areas, but even on a smaller scale in the industrial manufacturing or warehousing areas, enabling the use of the little autonomous mobile robots that just move stuff back and forth within a factory.
No, you're absolutely right, and. As a matter of fact, these fleets of automated robots in warehouses, that's already a reality, right? I mean, the corporate giants that have been running the world for the last year, because we've all been ordering online, are deploying these. I don't know, to be honest, exactly the protocol that they are deploying today, but certainly 5G will make that even more efficient and even more seamless. If you think about an autonomous robot that's coordinating with others, what they need is they don't just need like a bit pipe, right? I mean, the traditional Gs were just providing bit pipe that you could use to transmit data. Now there is this idea that the bit pipe has to be adapted to the specific situation that you are considering. So depending on the time of the day, depending on the situation, you can imagine that the bit pipe is not the same. And 5G will give that flexibility. It has the application in mind to actually enable the applications to run even more smoothly.
You're absolutely right. I think 5G gives the flexibility for all the multiple different types of communication. And also the last use case that you mentioned, the ultra-reliable low latency communication, gives us the performance that, that the industrial automation plants need to control some of these robots and to, for things like machine vision, where things need to happen virtually instantaneously, or at least on a much more deterministic basis.
Yeah, you are absolutely right. And I think that brings, the topic of safety, which is a legitimate concern when people hear about all these autonomous robots and vehicles being deployed. How do you guarantee that they are safe? Well, they are safe, essentially, if you think about a car, if it can brake fast enough, right? And that's where 5G, using that, ultra reliable, low latency mode of operation, can really revolutionize what's happening out there. Right now, if you and I drive our cars, I think the reaction time of a typical human is about 200 milliseconds. That's the time, between you see the situation and then you actually hit the brake. And now, if you're looking at what 5G is trying to enable, in principle, they plan to deliver a small message in 1 millisecond. Okay, so we're talking about an improvement of a factor 200. If it's just a comment that says brake, like the car detects that there's an obstacle coming way too fast coming in, brake, that's 1 millisecond, 200-fold improvement. And you can imagine that translates immediately into shorter distance over which you're actually braking, and safety is automatically improved. So I think that's where 5G is also likely to play a key role. It will actually make that safety possible. Another application that comes to mind, maybe that's further away from safety, but if you think about virtual reality gaming, I think it's something that's just starting. I think we've seen, headsets, commercial ones at least, being more and more affordable and being proposed to gamers. For virtual reality to work, you need to guarantee that there's not too much delay. If you have delay, people get dizzy, and that's not a fun game experience. And I think 5G is going to be a key enabler of that. Right now, a lot of these devices, they don't run really on any cellular network. They run on local networks. Maybe it's piggybacking on Wi-Fi. But I think with 5G, you can imagine that you'll be able to do, maybe virtual reality, outside your home, like in a field. And I think that's likely to completely change the industry. Don't take my words completely for it. I don't know any timeline on this. There are so many factors in play, but I think that's coming. We've seen that people are already willing to use their phone and look for Pokemons with a smartphone. So imagine what you could do if you start putting a headset on. That's going to completely change things. Gaming is a very interesting industry in that regard. They've been very good at innovating with things, and things that initially start as being very obscure and niche for hardcore gamers tend to translate pretty quickly into, mass consumer electronics.
Yeah, as a gamer myself, I've definitely tried some of the VR games, and, there have been some good games out there, but I can certainly see, with 5G, you gain so much interactivity and so much extra, it just incredibly improved the performance, I think, of the gaming, the gaming experience.
Yeah, absolutely. And you need that, ultra low latency to make that experience enjoyable to the end user. So, we've been talking already about a whole lot of examples that are really across completely different industries, right? All of these are just examples of applications that would benefit from 5G. And what's really even more exciting to me is there are probably applications that we haven't even thought about. People will probably come up with very creative services that are likely to change our lives.
Yeah, I completely agree. And, I'm looking forward to seeing some of those as 5G rolls out. And I think, 2021, it looks like it's shaping up to be the year where we're going to see much more deployment of 5G, much more rapid deployment of 5G in actual, in real cities and in actual use cases.
Yeah, you're absolutely right. And several operators have been, advertising their networks as 5G ready. And so they're actively, pushing in that space. And and for good reasons, right? I mean, they want to offer better services to their end users, more throughput, more speed. Now, I think it's a good segue into talking a little bit about the technology that's behind 5G, because I think if you talk to most users who've actually purchased a 5G phone, they might not have seen that much difference with 4G, to be completely honest. And that's because 5G is actually many things, as we've just discussed. And, people are sometimes advertised, whooping increases in throughput and speed that they might not see because there are several stages in 5G. And the first stage of 5G is actually an incremental evolution of 4G, with, better technology, if you wish, behind it, but doesn't fundamentally change the way you're transmitting your signals. But one big change of 5G that is likely to come soon is something called millimeter wave communication. So just to take a small step back and make sure we're all understanding each other's, the way communications works, you have a certain bandwidth. That's what's required to transmit your data, but that is being transmitted at a certain frequency. And your typical cellular network operates around a few, let me say one gigahertz for simplicity. All right, so 1 gigahertz is where your data lives, and around 1 gigahertz you can transmit signals, but you're limited because 1 gigahertz is finite. So what people are trying to do now is they're trying to push your signals towards much higher frequency, which corresponds to a lower wavelength. So that's the millimeter wave range that corresponds to, right now, the waves are centimeter with your current technology, and they want to go millimeter, so that's 1,000 times higher in frequency. And what that allows you to have a wider bandwidth. And that's where you can really see tremendous improvements in throughput, because suddenly you can carry that wide bandwidth. Now, that part of the technology, that's very new. People haven't used that much. And there are lots of challenges to deploying signals in that range of the spectrum. So to keep it simple, what's happening is that the higher your frequency, the more absorption loss you have, meaning that your waves don't go as far. And what that means is that you cannot transmit, to a very far base station. So communications have to be, cannot be as long distance as your regular, lower frequency communication. And so what people do to compensate for these high losses, they do what's something called beamforming, where they focus the energy that you're transmitting in one specific direction. Now, what you do by that is you get a very high link, very high throughput, but what you're losing by doing that is you're losing this omnidirectionality that you had at lower frequencies. So you see that we create a trade-off where if you're transmitting at lower frequencies, you have this ability to transmit at a lower bandwidth, but then what you gain is that it doesn't really matter where the receive antenna is, you're likely to hit it much more easily. Whereas if you go to higher frequencies, you have to focus your energy in very specific directions, which means there needs to be a more complicated phase where you find your receiver. And so that technology is more complex to deploy, and I don't think that's been fully deployed and not fully offered to end users yet.
Okay. Yeah. I mean, I'm somewhat familiar with millimeter wave communication because, like you said, I don't think everybody realizes that unlike 4G, 5G is in multiple bands and multiple frequency ranges. There's even a sub gigahertz band that they're trying to open up for 5G, if I remember correctly.
No, absolutely. So, and I mentioned earlier, 5G is many things, and that's why I think when you see networks telling you, "Oh, we're 5G ready," that can be a little bit misleading. I don't want to, point fingers or give names here, but certain operators are actually operating in the low band spectrum, so below 2.5 gigahertz, and there what they have is they have excellent coverage, because they don't need to worry about finding, receivers very accurately. So they have excellent coverage, but they're still at a low frequency, so they can only offer so much improvements in throughput and in speed. Keep in mind that we're talking about deploying essentially new base stations everywhere, right? So that's a massive undertaking for the operators. They essentially have to create these new transceivers that they have to deploy, say, in a city. And they have to do it from scratch because it's not just a software upgrade on an existing antenna.
Right. Yep. All new hardware and lots of new hardware, especially in the millimeter wave band, like you were saying. The distances are much shorter. Penetration is much more difficult through walls and whatnot. So literally, you'll have base stations. Potentially multiple base stations even within a house or a building.
Well, what you mentioned is interesting, right? The density of these access points will have to increase because, as you said, the transmission distance is lower, penetration is lower, so you will have to increase the density. But actually, it's very consistent with one of the objectives of 5G, which is to be able to support, an insane number of small 5G connected devices in a given area. I think the one of the target numbers that are advertised is you want to support 1 million IoT devices per square kilometer. And that's not going to happen magically. I mean, you need to be able to deploy enough base stations to actually support all these devices. I don't think one device can support 1 million devices. So they're going to be deployed slowly but surely. And I think we're moving away from really the traditional cellular network. I mean, the first generation cellular networks, everyone knows what they are. That's like a massive cell tower that's covering a huge area. But that has been shrinking over the different evolutions of the different Gs, where now we go from these what are called macro cells that cover huge areas to micro cells. Now people talk about, micro, pico, and femto cells that really correspond to very localized coverage, which has lots of benefits. It reduces interference between users, and that's what allows, improvement in throughput and speed ultimately.
So let's take a break from our conversation with Amit to talk about Mauser Electronics. Mauser Electronics delivers the widest selection of 5G components, including integrated front ends, amplifiers, RF connectors, RF passives, and antenna from leading manufacturer partners across the globe. Visit Mauser.com/empowering-innovation to explore more content on 5G, including articles, blogs, infographics, and videos. Security is always a concern for any wireless network, and 5G is no different, especially if it'll be as pervasive as we've been talking about today. Mathieu, one of your research areas has been security in wireless networks. How is 5G security different than what we've seen in previous networks?
Yeah, excellent question, Raymond. I think the big issue, the big security issues are to some extent inherited in 5G from what was not done in the previous Gs. I'm not saying here that there's no security that's being implemented in these protocols. They are secure to a large extent. But one of the big challenges you have in all these networks is that there's always a phase where at some point you have your cell phone in your pocket and you need to connect to a base station. And that's been one of the weaknesses of the networks, because that stage you start talking to somebody that you don't know. The best analogy I have is that, you're in a crowd and then you have to start talking to someone, and that's only when you start talking and engaging with them, maybe you build trust, and that's when you start relying on them. But cell phones are no different. There is that first stage, and that first stage is where I think many vulnerabilities are actually lying. And so 5G is not really different from previous Gs in that regard. And the problems that security loopholes could create are actually amplified because of the applications we mentioned. When suddenly 5G becomes a critical infrastructure to run, your autonomous vehicles, to provide remote surgery capability, and even, for gaming, you don't want somebody to suddenly hack your network and make everyone dizzy while they're playing their video game. So I think the applications of 5G amplify the security risks. So people are well aware of these. I think they're deploying more and more sophisticated solutions to actually take care of these issues, but there are still loopholes that people are trying to patch. And if I'm completely honest, some of these security issues have been deferred a little bit to 6G already. And again, I don't mean to say here that people should be concerned about their cell phones, but understand the moment you connect something to a communication network, you're opening yourself up. It's like opening the door to your house. And so there are, risks associated to that, and security protocols are here to mitigate these risks. So 5G is the way it's perceived. The way security is handled in 5G is I think a nice evolution from previous Gs, in the sense that it's less and less viewed as an add-on on top of your system. People have been realizing for many years now that you need to think your system with security by design from the ground up. The traditional approach of many communication systems was to say, well, let's first build the communication infrastructure, And then on top of that, let's add some security features as they are needed, as we discover vulnerabilities. I think with 5G, I mean, there's a whole working group of people involved in the 5G standard who are focusing explicitly on security, and they really try to embed security mechanism from the ground up into the protocol. But that's a complicated effort because security is a complicated topic. Very often there are things that are not envisioned when things are designed. There are problems that occur when systems are deployed, not when they are designed.
There's got to be that level of trust in the network before they'll even pick it up and turn it on.
Exactly. And from a research perspective, there are lots of interesting issues related to trust, as you said, confidentiality, privacy. And the irony is actually having bigger networks is not necessarily a bad thing, in the sense that, if you have malicious users, it's hard to completely overtake a network if you're just one user among billions, right? Usually bad things happen when you have many bad players taking over a network, but I think the density of 5G might actually create opportunities to mitigate that. Like you might not be able to trust any one, device in a 5G network individually, but you might be able to trust a group of devices that behave in a correct way. So there are lots of really cool, maybe more academic at that point, research topics that people are looking at, including myself. But I think this is all good news. Security is taken very seriously with all these new G networks.
Last time we talked a little bit about 6G. Are you okay talking a little bit about kind of the next generation?
Yeah, absolutely. And so what is 6G? So for 6G, people, maybe not too surprisingly, are starting to embrace a lot of the progress in machine learning that we've seen in completely different areas. But as algorithms have become better to classify cats and dogs, we've also learned a lot about how we can use them in different situations, including communications. And so I could talk forever about what's happening in that space, but to make things simple, let me put it this way. Right now, the way you design a communication system is as follows. You know that your communication system has to be transmitted over a certain physical medium. And that physical medium is complicated. I mean, if you want to think about wireless communication, the only precise way to describe that is to go back to Maxwell's equation and to compute and characterize how your waves are going to propagate in the environment. Now, as you can imagine, that's doable in principle. There's no way when you have your cell phone in your pocket, you're going to do these calculations to figure out how to connect to the cell tower. So what people do is they abstract that. Instead of working with Maxwell equations, communications engineer like myself, we use abstraction that are simplified models, if you wish. And these simplified models are good enough, meaning that we know that if we design a system for that simplified model, we deploy it in the field, it works. Now, the challenge is that these models are what they are. They are abstractions and they're approximations. And so sometimes they're good approximations, sometimes they're not so good approximations. And what machine learning, if you wish, allows you to do is it allows you to adapt the model a little bit more on the fly to actual changes or actual situation that you're into. So suddenly, if you're smart about it, you can use the base model as a baseline, but then you're using the specifics based on the data of what you collect where you are to refine that model. And that can lead to, significant improvements because suddenly your device is going to be a bit more efficient energy-wise. It's going to squeeze in a few more bits. And so I think that's what people are really excited about with 6G is they want to include this idea that we can refine, if you wish more, people would call that in a data-driven fashion, the models upon which the communication systems are designed so that they can be more agile. I like that word of an agile communication system that adapts a bit more to the environment. So the protocol is here to provide a baseline, but within that protocol, you have leeway to optimize things. Who knows what the world will look like in 10 years? I think there's really some big changes coming about. We're talking about autonomous cars, more automation. Some big changes are coming, and most likely, these things will happen gradually so that we won't be able to pinpoint exactly when they happened. But all of that is enabled by these really efficient and really powerful underlying communication networks.
Thank you for listening to this episode of The Tech Between Us. I want to thank our guest today, Dr. Mathieu Bloch of Georgia Tech. Mathieu, thank you so much for being with us and sharing your knowledge and insight on 5G.
No, thanks a lot for having me, Raymond. It's been a pleasure. I really enjoy doing more of these outreach efforts and advertise all the cool stuff that's happening, behind closed doors in engineering labs.
Yeah, no, it's absolutely fascinating stuff. And I love the behind closed doors insight that you've been able to provide for us today.
Yeah, no, my pleasure. Anytime. Happy to do that again. Anytime.
Thank you for listening to this episode of The Tech Between Us. In our next episode, we'll talk to Stephen Shackle, Business Development Manager for Power Products at ON Semiconductor, for a look at wide bandgap technology and products. Discover more Empowering Innovation Together content at mauser.com/empowering-innovation.